the tutorial. So we are going to continue with writing our cache server, and today we are going to work on stale data eviction. So let's jump into our IDE and start. So we will need our cache item will need a time to live, so a TTL. So we'll have time to live, which will be of time of type time.time, and then we will introduce another new data structure. We call it entry, which will be a structure, and what will it contain? It will contain a key of type string and a value, which will be the item. So how are we going to modify our cache struct to? So we are going to have our items are going to be, we change it from a map string item to a list element. Yeah, that is a data structure provided by the Go standard library that is efficient for this use case. And then we will have evictions. Eviction list will be a list of lists, and then our cache will also have capacity. We cannot store everything in memory, so we give it a capacity. So the capacity when it's full, we'll start evicting items, and this is what we are working on right now. So with that, I think we will need a background worker to periodically check the cache and evict. So we will also need two functions to evict the expired and then evict the list recent accessed. So let's write those. Let me have a function of the struct c cache, and it will be start eviction worker. It will take a duration. This will be of type time.duration, and we'll use the ticker from times package. And then after we create that ticker, we'll have a Go routine that checks and does. It will evict expired items. So let's go ahead and write the function to evict expired items. Pointer to cache, then it will be evict what is it going to do? We are going to get the lock. After we lock, then we defer the unlock, then we initialize a time let's initialize it to local time, and then we go over the keys. For key and item in the range of c.items, we check if now is so we are going to check if now dot after item dot value, then we cast it to entry, then dot value dot time to live. We'll have c dot evict list dot remove item. We remove that item and then we delete. Yeah, and then we will have the another function so to evict list accessed item. So func c a pointer to cache, we'll name it evict LRU. So what is this one going to do? I'm going to initialize the variable element. Yes, so it's going to return the element at the back of the eviction list. So if it's not nil, you are going to call that, and then we look for the key value. We cast it to that our intermediate data structure, and then we delete, and I think that's it. So let's let's now modify our set and get functions. So how is our set and get function going to look? Let's start with the set. So right now we are and then setting the value. I think this one is going to go for now, and then we are going to check if the item already exists before we set it. So if and then we are going to delete that key. So we are going to then check if our eviction length, if our eviction list is greater or equal to the capacity. And if that is the case, we are going to remove the least accessed item in our cache. So if c dot evict list dot len and then after all those checks, that is when we are going to put our item. So we are giving it a time to live of 10 seconds. You could add this so that it reflects your business needs and all that, or your system needs. So then we push, after adding it, we push it to the front. And that's it for how we will set items in our cache with the TTL, and also check for our evictions so that we evict stale items. We cannot keep everything inside the cache. So for ours, that was for set. For on get, we are going to have almost a similar thing. So we get, if we find that value, we move it to become the most recent accessed item in the cache, so that when eviction is happening, it is not evicted. So we'll keep on moving items we have accessed to the front, so that the algorithm works well. So what's going to happen here is, let's remove all that. So we are going to check if the item comma found if it's not found, we are going to check and let's log something here. Yeah, let's log, that will be a cache miss. And then if we're going to do that, and then we're going to return an empty and false. But then what happens if it's going to move it to the front, and then we are going to return, we cast and return that value. and I think we are almost done. Yeah, so how are we going to initialize our cache with the new changes? So we are going to have a variable here, C. So our new cache now will initialize the cache and start the eviction worker. Let's see if our code compiles. Go run main.go. Yeah, it compiles, and let's see, let's go to Insomnia and see if it's working. I think this is it. Let's send a get. Yeah, let's set. We are setting that, and we are getting. Yeah, so in the next tutorial, I will improve on the logging so that our trials can be seen very well. But just to recap, we went and included a time to live on our item. We created an intermediate data structure for converting these. We added data structures for fast retrieval and location of items in our cache. And then we modified our set function so that checks if it's full, it evicts. If it's not, if it's full, it evicts, and then it puts the entry in the front. And our get, if logs are missed, also. And I think that's it for now. So the next time we will work on data replication. So how nodes of this will communicate with each other over HTTP and replicate the data, and also how retrieving the data from the replicated nodes will work. Thank you, and I hope you found this helpful. You can share with somebody who will also find this helpful, and let's keep building. AI is not coming for our jobs soon. Thank you.